Alright, we're going to find molecular formula. So in this problem, problem 6, an unknown compound undergoes analysis and it is determined that it is 41.39% carbon, 3.47% hydrogen, and 55.14% oxygen. The actual molar mass is determined to be 116.07 grams per mole. Determine both the empirical formula and the actual formula. In the previous video, we converted the percents to grams for each of our compounds and then found the moles. So here, in the essence of time, we're going to do 41.39 divided by a rounded mass of carbon, which is 12, so I get 3.449. I know hydrogen weighs 1, so I'm going to divide it by 1. I have 55.14, and I'm going to divide that by a rounded mass of oxygen, which is about 16, so I get 3.446. Alright, so then now I find the smallest number. The smallest number in this case is 3.446. So I'm going to divide by 3.446, 3.446, and 3.446. Now, most of these numbers are about 1, so when I divide them, I'm going to get about 1. So I'm going to get about 1 carbon, 1 hydrogen, and 1 oxygen. So my empirical formula is going to look like this. And that's my empirical formula, but it's not just asking for empirical formula, it's asking for the empirical and the molecular formula. So what I do now is I find the mass of this. So I know that carbon has a mass of 12 plus 1 plus 16. And that is 29. So I do, the mass of my empirical formula is 29, sorry you can't see that. The mass of my actual formula is 116.07, so what I'm going to do is I'm going to get the molar mass of my actual compound, and I'm going to divide it by the mass of my empirical formula. So I'm going to do 116.07 divided by 29, that gives me about 4. So my molecular formula is about 4 times bigger than my empirical formula, so my molecular formula is C4H4O4. And that's how you do empirical to molecular formula.